Students, my name is Sumit Mehta. So in today's lecture, we will discuss some questions based on composition of functions and invertible function, or you can say inverse. Okay. So let me write down the question number one, which is based on composition of function. Okay. So students, here is the question, which is very lengthy to read. Okay, so we need to understand the question very deeply so that we can attempt the question. Okay, show that if function r minus this to this, so the function is defined from these range to this, okay, is defined by, and the function is given as this, and another function g from this range to this range is defined by gh is equal this, then f of g equal ia, identity function a, and g of f is equals to b, where a is this and b is this. So we need to prove that f of g is this and g of f is this. So first I am starting with students g of f x. So how we do is, in function g we put the value of fx. So fx is this. So in place of x in gx we will put the value of this function. So 7 times 3x plus 4 upon 5x minus 7 plus 4 upon 5 times 3x plus 4 upon 5x minus 7 minus 3. Okay, so expanding this function we will get 41x upon 41. So what we are left with, student, it is x only. So what we need to prove is g of f is identity function p, where b is r minus 7 by 5, because in the denominator part when we solve this, g of f, if this is not defined in the function, whole function will not be defined because we cut this, so it should not be equal to 0. So ib is equals to x, that we already proved. Now we will check off f of g of x. Okay, so this is f of gx, where gx is 7x plus 4 upon 5x minus 3. Okay, in place of x in f we will put the value of gx. Okay, so 3 times 7x plus 4 upon 5x minus 3 plus 4 upon 5 times 7x plus 4 upon 5x minus 3 minus 7. So after solving this, student, we also get 41x by x, which is equals to x. So what we need to prove is f of g is equals to ia, where ia is equals to x, which is an identity function. Okay, so that we proved already. So students, going step by step, we can say that f g is invertible function, or you can say g is the inverse of this function f. Okay, so in that way we can prove that whether g is the inverse of f or not. Okay, and in this question we also covered the composition of functions. So I hope, student, you are pretty clear about composition of functions and invertible functions now pretty clearly. Okay, and if you are still facing any question or any doubt, then please do comment in the comment section. I will be more than happy to help you guys there. Thank you. Happy learning.